We're going to take a second look at finding volume and look at the relationship between the shapes and just try to make sure that you understand which formula to use and when. So let's start with going from area to volume. For a lot of the shapes, the only difference between area and volume is multiplying by h, which is the height. You should notice that shapes that come to a point are multiplied by 1/3. So let's look at some common shapes. These two are both related to the area of a rectangle, which is length times width. So on the left, I have the volume of a box, which is length times width times height. But on the right, where I still have that rectangular base, I can see that it goes up to a point, which means I need to multiply by 1/3. So the volume of a pyramid will be 1/3 length times width times height. When you look at a pyramid, you can kind of just look at it being the 1/3 the area of the base times the height. So if the base was a square, I would have side times side. If it's a rectangle, it's length times width. So I can just change this, whatever the base is, use that area, do multiply by 1/3, whatever the base is, times the height. We'll see that again when we go on to circles. So here I have the area of a circle is pi r squared, and then I have three shapes that are related to volume that all use circles. So the first one's a cylinder, and this one's pretty simple. I take the area of a circle, pi r squared, and I multiply by h. Here's that point again. So anything that comes to a point, I have the 1/3, area of a circle, pi r squared, and then times the height. The last one, you really just have to think about this one and memorize it, that it doesn't relate to the other one so well. The volume of a sphere is 4/3 pi r cubed. Of the shapes we have, in this section we're talking about volume, it's the only one that doesn't have a height associated with it. So remember, sphere is the radius, is the measurement in every direction, and there is no h at all. But if you go backwards, you can see. When we talked about area of a rectangle, right, and went to volume of a box, length, width, height, volume of a pyramid, 1/3 length, width, height, there's heights there. Height with a cylinder, height with a cone, no height with a sphere. So because there's no height, that pi r is now cubed, and it's a 4/3 as a multiplication. Right. So again, let's go to similarity. The similarity I want to point out is when it goes to a point, you multiply by 1/3. So same for the cone, 1/3 pi r squared h. Same for the pyramid, 1/3 length, width, height. So I want you to think when it goes to a point, make sure you throw that 1/3 in. As a point of clarification, though, kind of feels like there's a point, but it's not. Prisms are not pyramids. So I want you to look at the shape and see where it kind of looks like a ramp. It's not going in every direction to a singular point. I have a bunch of stuff. It's, this whole line that's the same. So this volume of a pyramid, where it's a triangular base, is going to be, the volume is 1/2 base times length times height. Let's look at that a little better. Here's an example with dimensions thrown in. So I have an 8 on the bottom, a 9 is the height, a 10 is the hypotenuse, and a 5 is like running this length down on. So this is how I wrote it. I want you to notice the base is 8 centimeters, the height is 9 centimeters, and the length is 5 centimeters. That 10 centimeters, you don't use it. So it's in there. It's fine that it's in there, but we're not going to use it. So this volume I would be 1/2, because we have a triangle. So I'm doing base times height. So 1/2 the base 8 times the height of 9, and then that length that it's running is 5 centimeters. When I multiply that together, I get 180 cubic centimeters. Let's try that again. This time I just wanted to show you two things that are related. So I have two, you'll watch them, here they come, 2/10. So in this first one, the dimensions of the base are 6.5 feet by 6.5 feet with a height of 65 inches. And I want to find the volume. So the first thing I'm pointing out is this is a prism, not a pyramid. It's going up, and there's a line where it's the same. It's not going to a point. So we need to start by converting everything to feet. The 6.5 feet by 6.5 feet is fine, but that 65 inches, let's just divide by 12 to find out that's 5.42 feet. So that's not a very tall tent. I can say I for sure cannot stand up in that one. Here, when I look, I have this square base of 6.5 by 6.5, and then I have the height of 5.42. So because this is a prism, I'm going to do 1/2 base times height, and then times length. So I have 1/2, 6.5 times 6.5 times 5.42. Remember, it's multiplication, or it doesn't really matter. It's the idea I had a triangle. The triangle brought the 1/2 in. And then the length, the width, and the height, the 6.5, 6.5, and 5.42. I threw that all in my calculator. I got 114.5 cubic feet. So just change the shape, and this is my other tent that I have, and the dimensions here are 11 feet 8 inches by 11 feet 8 inches with a center height of 92. Again, I want to find the volume, and this time we want to start by thinking, let's turn everything into feet. So for this feet, I need to say, well, the 11 is fine, but the 8 inches, I need to convert that to feet. So I do 11 plus 8 over 12. So that 11 is the feet, 8 over 12 is the inches. So here's my conversion. It gives me 11.67. I have two of them. So I have 11.67 times 11.67 for my base. My height was 92 inches. I'm going to divide by 12. It gives me 7.67. So this is much higher. For this tent, yes, we can all stand up in here. This is 7.67. All right. This time it is a pyramid. So with a pyramid, I use a third. Prism, I use a half. Here for the pyramid, I use a third. So I have a third. I do the length, the width, and the height. 11.67, 11.67, and 7.67. I end up with 348.2 cubic